pre-recorded, but we're going to leave time at the end for questions, and also the chat during the session is available. We'll definitely be monitoring it. I'm not going to go take a nap or anything. So here we go. Let's see if I can share the video. Oh, you know what? Sorry, I know there's some special settings. Yeah, I didn't click on that. There we go. All right.
Everybody, welcome to part 2 of the Board of Trustees Key Performance Indicators Dashboards presentation. My name is Chris Lehman, and I'll be joined virtually today by Nick O'Day. To start with, I wanted to show you what our Board of Trustees KPI dashboards used to look like. We called this a dashboard, but it was really just a PDF file with a bunch of PowerPoint graphs. And this actually was a very effective way to present the information. You can see that we have % first-time freshman applicants admitted over time, the University of Illinois at Urbana-Champaign compared to their peers. There's a lot of good information in this chart. The only problem is it's just not very accessible in a PDF form, and it's just hard to find what you're looking for as well. So this is the same data, new freshman % admitted, in a Tableau dashboard in the new BOT KPI website, as we call it. This is obviously much more dynamic. It provides an easy way to find metrics by area at the top and by dashboard below that, and by the university selected with the logo below that. And then you can see where you can choose your metrics as well. I'm not going to spend any more time on showing this. Hopefully you were able to see part 1 where you could see a live demonstration of the website. I'm going to talk more today about kind of the behind the scenes aspects of this. And I will start first with the website itself. Just to note that it was built iPad first, which really just means we wanted to make sure it worked great on an iPad, because that's what we anticipated most of our board members would be using to access the site, since they have their iPads at the ready during board meetings. But we also definitely made sure to design it so that it was responsive design using cascading style sheets, so it will adapt to any or all devices that people may want to use with it, even phones. And people have pulled it up on their phone and have given us positive feedback. We also wanted to make sure that there was plenty of code reuse going on, so that we could be very consistent throughout the site and the way it's designed and functions. We have reusable headers and footers, and that's done with Cold Fusion. We also have function calls with parameters in Cold Fusion for any dynamic data that we may bring in from our database. And finally, JavaScript is used kind of a lot for just various functions of the site, and also for actually bringing in the Tableau dashboard in an iframe with a API call to the JavaScript API. We also spent a lot of time making sure that the site was accessible, and I actually gave a presentation yesterday on just that aspect of this site, so hopefully we're able to check that out. So again, what's going on behind the scenes here? There's a ton of data. I don't want you to panic or try to read all of this. This is just to give you just a rough idea of how many metrics we're looking at. It's over 100 metrics. You can see it broken down by the different areas and dashboards. And the thing I really want to point out is you'll keep seeing IPEDS, admissions IPEDS data. Enrollment is from IPEDS, tuition and financial aid, graduation retention, degrees awarded, et cetera, et cetera. So obviously IPEDS is a big part of this. So the data in our previous dashboards, PDF dashboards, were pulled by hand from the IPEDS data center, which works, but it's time consuming, especially when you have so many metrics. It can be especially problematic, as we learned, if you have to change peers in your peer data set on the fly, which happened to us once. So then you have to pull all of the data with the different set of peers. So we decided to create a local IPEDS database to speed up the development of these dynamic dashboards. There's a couple different ways you can get a hold of the IPEDS data from NCES. One of them is with their IPEDS access databases. So I'm just showing you that website where you can pull those access files down. They go all the way back to 2006-07. And that has all the IPEDS data within a single file for each of the years. And you can see that right now the 2018-19 data is provisional, but they have the release dates there and everything. There are also the IPEDS complete data files, and these are kind of closer to the raw data from what I understand in IPEDS. They're not manipulated in any way. They're just formatted for a couple different programs here. The data file itself that's listed is a CSV file, but they're also SPSS, SAS, and Stata versions. The differences between the two, some of the differences, the IPEDS access files are updated only twice a year, and they're updated once when the provisional data is complete and also when the final data is complete. And the complete data files are actually updated kind of all the time, just whenever new data is available, data is revised, they'll add it to the website before they will publish an updated IPEDS access database. In terms of IPEDS access, there also are value-added tables, such as derived tables. I know a lot of schools use those, including us. There are also some SIP roll-ups that are embedded in a few of the tables. The complete data files don't have those derived tables or other value-added tables. And another difference, the IPEDS access data only goes back to 2004, whereas the complete data files go all the way back to 1980. Although when the further you go back past 2004, the differences in the data formatting or the columns themselves become kind of a problem. The IPEDS access you could think of as kind of a final snapshot, whereas the complete data files, it's more of an in progress kind of thing. So I say here at the bottom, which is better? It depends, of course. I'd say, in some cases, one is maybe better for one purpose than the other. So why not create two databases, one based on the access data and one based on the complete data files? So I went ahead and did that. I'm just going to show you the access database version here. And what you're looking at is an Alteryx workflow. I actually was able to get a single license of Alteryx for our office, basically just for this purpose of working with the IPEDS data, although it's come in very handy for all sorts of other things after the fact. But the thing I really like about this is, or a couple things. One, it's very easy to work with all sorts of different kinds of files, and you'll see, this is very self-documenting. As long as you label things properly, it's pretty easy to follow what's going on here. So I've just created all these kind of steps in the workflow. The circles that are just blue with no icon are actually macros that I created so that I can loop over like a list of files, in this case, all those access database files, and do the same tasks to all files in order. So this just imports those access database files, and actually that first step goes directly to the website itself. I haven't even downloaded them. I just kick this off with that run button, and it goes and pulls the files directly from the internet. And that's great because when they're updated, and sometimes they are updated, every time we run this, we'll have the very latest information. Whenever I need to update this for a new year, all I have to do is just add the new year URL to the database files listing and then hit run, and that's all. That's it. I'm done. The end goal here is to get this information into our SQL Server database, and that's what's happening on the far right there in each of these tasks is once all the processing is done, then we're dumping the tables into the SQL database. So I don't want to go into too much detail on what these things are all about. That could be a whole nother presentation unto itself, but I did want to just explain generally how we're making this work. So obviously we need to do trend analysis. We need some longitudinal data. So I create in Alteryx, and actually let me go back. You can see that I'm creating these longitudinal tables here. Longitudinal data tables are down here. So I'm just going to take all these tables, kind of merge them together, put an all at the end, and then I'll have my table. So first, I'm loading all of the separate year tables. For example, for admissions, I've got a table called ADM underscore all. And all this is combining ADM 2014, 15, 16, 17, 18 into a single table, ADM all. Now, the thing that's really great about Alteryx in terms of this is it handles differences in files almost magically, really, because that can be a big problem when you're trying to write like a SQL query to union a bunch of tables, and one table has 12 columns and the other has 15. So Alteryx just kind of handles that complexity for you and gives you all the columns. Some of them, of course, may be null in certain years, but you just don't have to deal with it. So I have an all table for admissions. I have an all table for academic libraries, completions by program. So all of these things are just the combination of those year tables. And the year tables are also in the database if you would like to use those, but the all tables are really for the longitudinal or trend analysis. So how does this actually work once these tables are in our database? How would you write a query against it? Well, it's actually really easy, especially if you're used to pulling data in an ad hoc way from the iPad's website, which is what we did for many years. So if you go to the site and select your variables and select your institution, and at the very end, you just output the short variable names and you output to the screen, which is what I did here, then you'll see, I got my unit ID, my institution name, and then my enrollment total, and this was for 2018, and for the level, which I'm pretty sure that's undergrad, if I remember correctly, EF level equals 20. So I have all these same variable names in these tables because this data is coming right from iPads. So if I wanted, for instance, to get all years of data, not just 2018, for this enrollment, fall enrollment, then I would select, there's EF total, that's my variable right here that I want as output, and the year, which will not be here, obviously. And then I make sure I'm only getting unit ID 145637 in the where clause, and EF level is 20. So I just use this EF all instead of EF 2018, and then I get all the data that I need for those metrics. I also wanted to just quickly show you that HERD data, higher education R&D survey, is used in our KPI website and the dashboards, and that's another actually very easy in Alteryx thing to do. This is actually, these files are Excel and not CSV, but I just brought in all these Excel files individually. I did download them in this case, although like I said, I wouldn't have to do that. I could just pull them from the web, and then created tables, individual year tables, and then it's pretty easy to see. You can imagine that all I'm doing here is letting Alteryx combine all these individual year tables for me with this union operator into my HERD all table, and then we can pull from that when we run the queries that drive the dashboards. Let's take this out of the theoretical realm for a minute and move into the practical and take a look at an actual longitudinal table that we've created from the Access database, iPad's Access database. This is the GR all table, you can see that there are all these columns here, GR race 20, 21, 22, etc., that have data, a table year, which we've added, and then all these columns to the right of that, which are empty. So let's investigate that a little bit. So there are these utility tables, they're called, that NCES provides in their access databases of the IPEDS data. And they give you all sorts of useful information about the tables and columns themselves. So if we look up the GR tables, then we find out that its graduation rate for full-time, first-time degree seeking undergrads. I'm sure many of you are familiar with that IPEDS definition. We also get some other useful information about when the data was last touched, and if we're looking at final or revised data or provisional data. So let's go back and look at that table again, and let's try to dig into this a little more. So 2006 is that's what the data is looking like. 2007, kind of the same. So why don't we go take a look at one of these columns in particular in that utility data once again. So let's look at that GRN-RALM, this one right here, and why is that empty and what is that? So if I query that utility table, the var table as they call it, for that variable, then we'll find out right away that that is non-resident alien men. Okay. Let's keep going a little further with this. If we go into 2008, now we see that these columns over here are all filled in. And now a couple columns over here on the left are not filled in any longer, GR race 23 and 24. So some of you, I'm sure, are already thinking of what's going on here. It's got to be race ethnicity related. And if you remember your years, that's when there were some changes made. So, but let's just keep looking just to make sure. So yes, GR race 23, if we look that up, is race ethnicity unknown total, okay? Let's just go all the way to the most recent data in 2018, and now you'll see, wow, look at all these null values. So let's look up this GR race 22 column just to see what that is. And we'll see again, white non-Hispanic total, and this is even marked in some of the years for some reason and not in others, I don't know why, old. So this is giving you some great information. Now, not just the information that I wanted to touch on, but also just, again, to hammer home that when I put this together in Alteryx, I didn't have to worry about, this year, that in 2006, that these columns existed and these didn't. And then in 2018, that these did and these didn't. That unioning operation was just taken care of kind of automatically for me by Alteryx, which is really nice, especially going forward if changes happen, which undoubtedly they will. So I won't even have to really worry about it. Another thing to quickly touch on is the KPI table, BOT KPI table, as we call it, that helps keep all of this data in the dashboard organized. Don't worry about reading all this, but this is just to show you what this table contains. And I'm going to show you real quick how this maps to the dashboard itself. So on the dashboard, the Tableau dashboard here, we have these fields from that table. So let me show you this table again. You've got your KPI full name 2, the short name, the summary, the footnote. So all of these things are tied directly to this dashboard through that table. And so this really helps keep things nice and organized, keeps us within our field limitations for the display, because obviously we're working with a limited size here, that iPad first design, as I mentioned. And so you can just see how those fields all map to the display, the summary, the comments, the footnotes, the short name, the university, subcategory name if we have that, and some we do. And then this table becomes especially useful when we start trying to figure out what are all the metrics that we have and what areas do they belong to. So you can see I highlighted here the metric inventory on our website. So if you click on that, you actually get a list organized by area, by dashboard, of all the different metrics in order. And this is actually derived or built right from that database table that we were just looking at. So this is really handy. Then if we ever need to change this, we just go to the database table and then this will update automatically. Another nice thing, because the Tableau dashboard is built with parameters, these are actually links here that will take you directly to that particular metric in that particular dashboard. So if I want to look at new freshman ACT math percentile data, I can click right here and go right to that data. And that's really nice, especially for board members when they're presented with a lot of data like this and sometimes they're trying to find something very specific. So they can go right here and they can get right to the ACT math percentiles if that's what they want to see and take a look at that. So that's all for me. I'm going to pass it over now to Nick O'Day.
Hello and welcome, everyone. Thank you for attending our presentation, and thank you to Chris for the nice handoff into my presentation. My name is Nick O'Day, and I'm a Resource and Policy Analyst within the UI System Office for Planning and Budgeting. Today, I'll be presenting my part of Part 2 of our Board of Trustees Key Performance Indicators project, which explores building the data behind the dashboards and creating the dashboards themselves. Part 1 in Chris's presentation did a great job of giving us an idea of our legacy reporting style and process and how we got to where we are now. As you've heard my colleague Chris describe, we used a tool called Alteryx to pull all of the complete access database files from the iPad's website and transform and load them into our SQL Server warehouse. Once that raw iPad's data is in the warehouse, it still needs to be transformed into meaningful data sets that are capable of producing the visualizations we need for our KPIs. Let's take a quick look at one of our old PowerPoint visuals as a reference to determine what exactly we'll need to recreate these visualizations in Tableau. Using this chart here as a reference, we can identify that we'll need the following components to our data build. We'll need the year of the data here. We'll need our own university's data represented by the values in the blue bars. We'll need some sort of a university or peer group identifier to distinguish between universities. We'll need the values for our peer percentile calculations represented by these 3 colored lines. We'll also need some sort of metric ID or identifier or label. That's going to prove useful later. So for this example, we're calculating our freshman to sophomore 1-year retention rate. We're calculating that by dividing the number of the current year's returning full-time students by the prior year's full-time adjusted fall cohort. And I'm more than happy to share specific IPEDS fields, table references, definitions with anybody who's curious about that after the presentation. But for now, let's establish that as our base calculation that will return our 1-year retention rate at the institutional level. So now that we have that piece, our next piece would be identifying the peer percentile figures. Before I get too specific into that next formula, I'd like to talk about one of the key components to these data builds, and that's the use of our user-defined scalar functions. So let's open up SQL Server here and open our iPad's database and open the programmability folder, open our functions folder, open our scalar valued functions folder, and let's take a look at our peer group flag scalar function. So here we can see what our peer group flag scalar function syntax looks like. A very basic definition of a user-defined scalar function is that they take one or more parameters and return it to a single value. For our purpose, these scalar functions are acting very similar to a case statement. Perhaps the single most important scalar function we're utilizing here is what I'm showing here, is this peer group flag. This scalar function takes the unit ID parameter from iPad's data and returns a single peer group value, in our case, Urbana, Chicago, or Springfield, based on our own definitions. For those familiar with SQL, you might be asking, if it's like a case statement, why not just use a case statement? And that's a very good question. Case statements are very useful, but they do have limitations. We could use a case statement to define our peer groups in a select statement, or use them in a where clause, or use them to identify the partitions within the percentile function. But what if that would ever need changing or updated, such as a last minute change to the peer groups? Well, that would mean we'd manually have to go in and update our case statement everywhere it appears within our queries. And since we report over 100 BOT KPI metrics, that's a particularly daunting task and a lot of manual updating. So one of the big strengths of scalar functions is that they function at the database level, meaning that once and if they are updated, those updates will cascade down and be reflected in any place where the scalar function is being called. You can make one change and it will be reflected in any and all queries and tables. Now, of course, you'd have to drop and rebuild your tables with your new definitions, but no matter where that function is embedded, whether it's in a simple select statement, in a where clause, or it's even embedded inside a calculation, the function will return the updated values across the database. In the example build that I'll show in just a few moments, we'll see the peer group flag scalar function appear in 3 different parts of our query: the select statement, the where clause, and within our peer percentile calculation formula. Now that last part, the peer percentile calculation formulas, that's where I believe our user-defined scalar functions really prove themselves useful. And we'll go ahead and step through the syntax and the components of the percentile function to show examples of just how those scalar functions work. So if we look here at this top part, these highlighted lines here, that's what our base percentile function syntax is going to look like. So in order to calculate the 25th percentile, after the order by statement is where we'll insert the field or the calculation that we want to compute the percentile for. So for us, for this purpose, we want to calculate the 25th percentile for the 1-year retention rate. So here is where we put our calculation that's going to return our 1-year retention rate at the institutional level, that calculation that we established earlier. We move to the over part of the function. This is where the function asks us, how do you want to segment your data? How do you want to break it up? How do you want to partition your data by? And now this can be more than one column if you need. And finally, we'll finish with an as statement to label our percentile calculation. So for this example here, I've selected just some segments of the logic for the data build for our graduation and retention rate dashboard. So if we look at line 20 right here, here's our actual calculation for that 1-year retention rate. And you'll notice that we're doing some casting of these 2 fields right here. And that's because the default data types right here are integers. So whenever we're dividing an integer by an integer in SQL, a non-integer result, such as a percentage, like we'll need here, those aren't allowed. The result will always be 0. In order to obtain a non-integer result like we want, we must first convert or cast, the numerator and denominator to a non-integer data type. So let's see what this will look like inside of our percentile calculation. Let's put a little space here. So to calculate the 25th percentile for our 1-year retention rate, we're going to order by, and here's where we're going to insert our calculation right here. And then as we move to the over part, here's where we're going to partition our data by, and then here's where our scalar function comes into play. We're going to partition by our scalar function for our peer group flag that's going to distinguish the percentiles for the different peer groups. And we're also going to calculate it along each table here. So before we execute this, let's go back and find everywhere where our scalar functions are being called in this query. See in line 16 right here, I've actually got 2 scalar functions being utilized, our peer group flag and another scalar function called the UI system flag, which just simply identifies every single University of Illinois System University with a Y or an N flag. I've also got the peer group flag in the where clause. Now, if we go back to our modify syntax here, most of the time, I'll say where the peer group flag does not equal other, and that will limit my query to every single peer institution that's relevant for our 3 system universities. But for this example, I'm only pulling down Urbana-Chicago, and I'm only pulling down 2 table years just to provide a smaller data set that we can work with for the purpose of this illustration. But this is a great example that shows the versatility of scalar functions and the number of different ways that you can use them within a query. So let's go ahead, this following section of code. Okay. So we can see here, just from this snippet of the data set that we've pulled down, our Urbana and our Chicago peer groups for the 2014 and 2015 table years. Now we would need to pull additional years from the all tables that Chris built to build our final data set. But again, for the sake of this example, I've limited this query just for the purpose of this illustration. I will add that these two columns, the prior year fall cohort and the current year full-time student values, they're not actually needed for our visualization, but I do prefer that they be included in these initial data builds, so they help me verify that our calculations are correct. So what's most important to notice here is the unique one-year retention rates at the institutional level. As we can kind of step through the rates for each university here, and to see how those values, or excuse me, this repeating value along this peer group and along this table year. So we've got 10 records selected here for 2014. We can see that that value is repeated for the entirety of the 2014 table year. If we move down to 2015 and select the next 20 records, we can see that that value is repeated for the entire 2015 table year. And as we switch to the Chicago peer group and the 2014 table year, we see that that percentile value changes again. So since those percentile values are changing on each table year and for each peer group, we know that our function is working as we want it to. But just for the sake of this example, let's see what happens to that calculation when we pull the peer group flag out of the partition by statement. So same segment of code as we previously ran. The only thing we're going to change is our partition by statement, where we're no longer going to have our peer group flag in the partition by. Let's go ahead and execute this. Oh, missing an order by statement. Okay, so if we look here, I can see that I've got two different peer groups here within our first 20 records. And look what our peer 25th percentile value looks like. That value is repeating along the entire 2014 table year, and it changes on table year, but it does not change with the change of our peer group. So for our purpose, that would be incorrect. So hopefully these few minutes have provided you with a brief high-level understanding of how scalar functions can be created and used within SQL queries. I've found them to be an invaluable tool when creating my data sets. So now that we've identified a methodology to create our peer percentile calculations, it's time to finish building our data sets for our dashboards. So let's go back. Let's re-execute the right part of this code. Let's look at the rest of this data set. So you'll notice this column right here, this UI system flag. This is the other scalar function that I referenced earlier that identifies an institution as a UI system university. This is important not only to quickly identify our own institutions, but it also helps us limit records to only the records that we need for the next part of our data build. As we think about building visualizations in Tableau, I found it easiest to have tall data sets with few columns instead of really wide data sets with many columns. Now, there are times where you may need a wider data set, and I'll show you an example of a dashboard built on a wide data set later in this presentation. But this type of tall data set design offers the opportunity to consolidate many different values that might need to be displayed into a singular column, which we're going to call our metric column here, as you'll see in a moment. But I find this tall design to be a much more efficient way to build dashboards within Tableau. So I've used just a small sample of this dashboard data build to illustrate how and where scalar functions can be used. And ultimately, these retention rate metrics are calculated along with graduation rate metrics. And all of this data at the institutional level is stored in a custom, what I call a staging or a prep table. For our next data set, we'll want to select all of the records from this prep table that have a UI system flag value of Y. Now, while this drastically reduces the number of records from our data set, we're still left with a very wide data set. We need to think about a way to essentially pivot this data into a structure that's more friendly for dashboard design. So let's open up the second part of our dashboard build here and execute this command at the top of the list. So this from table right here, this graduation retention rates, that's the staging or prep table that I'm talking about. We would have built that in our initial phase of the data build. So let's go ahead and execute this here to look at the difference in what our data set's going to look like. So we can see here that we've checked off nearly all of the data needs that we've identified earlier in our presentation. We've got the table year, we've got some institutional identifiers, we've got our peer group flag there, we've got our metric there, and we've got our peer 25th, median, and 75th percentile values. We've got a label, we've got this KPI ID. Chris mentioned the KPI ID briefly in our KPI tables. This field is going to come in handy, particularly when we're linking these two different data sources within Tableau, and I'll touch more on that in a little bit. But if you think about this, it all looks great, but what are we missing? Are we missing anything? We look back at our PowerPoint, we can see that there's no leading university data. That is, that there's no University of Illinois values without peer percentile calculations for the same year. So we can see here in this chart, we don't have percentile calculations for the 2017 and 2018 year. Granted, this is old data, but my point remains. We are going to need some leading university data in this data set, and we won't be able to get that all from their IPEDS database. So that data source is going to vary a little bit by institution. So we won't get too specific into that. If we execute this entire data build here, our bottom rows are going to give us an example of the kind of data that we're going to need here. So for our retention rate, these three records right here, we're going to need extra leading university data records. So ideally, we want to have this separate leading university data in a structure that makes it easy to blend or marry with our existing IPEDS data. Fortunately, with only 3 system universities and only 1 or 2 years of leading university data needed, we won't have a very big data set to marry with. Since it is so small, it's very quick and easy for me to just insert these rows and insert this data into an Excel spreadsheet and simply import that spreadsheet as a table into our SQL Server database. Now, when doing this, it's very important that I build this new table with the same structure, specifically the same number of columns and preferably the same column names as our IPEDS data, because we're going to be using the union all command to marry these two data sets into one another. Now, for the sake of this presentation, I've saved us some time and skipped through the import using the SQL Server import export wizard, although again, I'd be happy to go over that with anybody if they have any questions about it later. But now that we have our 2 initial data sources ready in the database, we can proceed to the final step of our database build. And this is where we're going to union parts 1 and parts 2 together, like I've talked about, to create that tall data set that we want that includes our IPEDS data as well as our own leading university data. So looking at our final result set here, we can observe that we've got IPEDS peer data for a handful of years, as well as leading university data for several years. So a quick note on this. Tableau can connect to tables or views within a SQL Server database, so it's ultimately up to you to decide if a table or a view is better for you. I came from an environment where we had lots of users querying a data source at one time, so we opted to store that data in views in order to restrict the access to read only. That is, you couldn't update the data, you couldn't delete the data, you couldn't make any additions to the data within those views. And that's great for ensuring data security, but it also requires dropping and rebuilding the view if any changes might need to be made to your underlying data. So with that being said, tables offer a bit more flexibility than views do. So if that's more important for your needs, I might recommend opting for a table rather than a view. Now, all that being said, we're ready to start building some dashboards. Now, I can more than likely give an entire presentation on just the dashboard builds alone, so I'll try to keep the rest of my time to covering what I believe are the most important parts of our build. So the main goals and objectives that we wanted to achieve when we're building these dashboards were to reproduce the visuals our trustees were used to seeing and that they're comfortable with. We wanted to show them the underlying data in a table format to help reinforce understanding. This was actually a specific request from one of our trustees. We wanted to create interactive controls for our users to be able to switch between various metrics as well as switch between different universities. We also wanted to leave room on the dashboards for any summary comments, descriptions, additional campus comments, and any other supplemental information that may be needed to provide important context. We also wanted to personalize the dashboard a little bit for each university, and that's means utilizing different university colors and some logos on the change of university. So each one of these metrics tells a little story, and as many of us who work with data, reporting, visualizations, etc. know, just the graph alone doesn't tell the whole story, and sometimes that can be misleading, or perhaps lead somebody to a conclusion that you may not have seen yourself. And that's why it's important that we leave space within the dashboards for some additional comments to help explain the data and tell the story. So I've chosen to start here with our graduation and retention rates dashboard because it includes sufficient representation of metrics that have that leading university data, as well as our peer percentile calculations, while also being a relatively simple dashboard design compared to some of our others, which again, I'll show you an example of a more complex build in a little bit. For those of us who are not very familiar with Tableau, everything starts with a worksheet. A dashboard is simply a collection of worksheets that work together to produce a cohesive display. So in our graduation and retention dashboard here, we're utilizing 7 different worksheets to produce one dashboard. Those worksheets are the graph worksheet, the table worksheet, the logo sheet, the title sheet, our legend worksheet, our campus and summary comment worksheet, and a footnote worksheet. So going back to our graph worksheet, it's just what it sounds like. It is the worksheet that we use to reproduce the graph inside the PowerPoint. This is a combination chart R, and our peer percentile calculations are represented as lines as part of the measure values here. Note that again, we don't have a peer percentile calculation for the last year of the data set. Now, a quick comment on a design practice here that's consistent throughout the charts on all of our dashboards. By dragging the university field, and again, this was from our peer group flag scalar function, by dragging this university field onto the color card in the marks shelf, we can customize the colors of the bars based on the values in that university field. We've assigned each university a custom color based on the RGB configurations that match our official logos. So as we switch to Chicago, we get that nice deep Chicago red. As we switch to Springfield, there's the Springfield blue. The same kind of idea applies with the measure values for the colors for each of our peer percentile calculations. Now, to achieve the combination of bars and lines appearing on the chart, we have to use a special chart type in Tableau known as a dual axis chart. This type of chart graphs one metric on one y-axis and the other metric of choice on another y-axis. Tableau conveniently allows you to synchronize these axes, which is what we're doing here. That ensures that the scale of both axes is the same. For example, we're not looking at 1 to 10% on one axis and 1 to 100% on another axis. So next, our table worksheet is a very simple table that features our metric and percentile values displayed in rows with columns for each year of the data set. We can again see the lack of the peer percentile data for the last year of the data set here. Go ahead and skip to our campus and summary comment worksheet. This worksheet, along with the title and footnote worksheet, utilizes a separate data source than the one we've previously built. I think Chris touched on this a little bit. We've created one big table that stores all of the text information that we want to see displayed on the dashboard. For the sake of time, I won't get too deep into that, but what's important to know about utilizing all of these different data sources is knowing how to connect them within Tableau. So earlier in our data model builds, we referenced the use of the ID or label field. And those ID fields are in both the text table data source and all of our metric data source tables. And these ID fields allow us to create blend relationships between different data sources, very similar to joining tables within Tableau. In this situation, I link the data sources together using a combination of two fields, our university field and our KPI ID. Doing this allows for a unique combination in each table that only returns one record. Now, as we grow our text table over the years to store more comments, footnotes, and other context, I'm applying an additional year filter here within the text worksheets to avoid returning duplicate comments for one metric. Flip back to our logo switch sheet here. This is a worksheet that switches the university logo at the top right-hand corner of the screen upon a change in the university parameters. Let's go back to our dashboard, change our university here so we can get an illustration of that. This worksheet actually uses the image files for each university logo as a background image, along with a few other clever Tableau tricks to display just the logo itself. Now, this last worksheet is a great example of how you can manipulate worksheets to function similar to default objects in Tableau, and that's our legend worksheet. By default, Tableau would provide a legend that identifies which color represents each percentile line, and that's great. But the problem with that legend is that it's inflexible. It doesn't have the capability to appear or disappear on the change of certain metrics like a worksheet would. Fortunately for us in this graduation and retention rate dashboard, all of our graphs look the same. So our legend applies to all of our graphs. There is no need for me to hide this legend worksheet within the dashboard. But as I'll show you in a minute or two with a more complex dashboard, we will have situations where it is necessary to hide it. But perhaps the most important part of these dashboards are the custom parameters that we've created that allow for switching between metrics in universities. You can see them listed on the left-hand side of the dashboard under the Select a Metric heading and the University heading. Now, some dashboards use quick filters and some use parameters. Each option offers its own advantages and disadvantages. Quick filters allow you to simply use fields straight from your data source as a way to choose which records or data you want to display. Parameters are similar to quick filters, but offer a little bit more flexibility when it comes to dashboard interactivity. Parameters can be values added directly from a field, or they can be custom strings. Parameters are workbook specific, while quick filters are worksheet specific, and that's a very important distinction to make and understand. Parameters being workbook specific means that you can apply parameters across different data sources, like we need to have for this project. Quick filters are only good for the data source that they come from. Quick filters also allow for multiple selections. Now, that may be needed for some purposes, but for our trustees, we design the dashboards so that we're only focusing on one KPI at a time. Parameters are also very important in our case in order to allow the dashboards to communicate with the website framework. Quick filters cannot be passed through the dashboard. They can't be read by any of the JavaScript like parameters can. This function is critically important as our website includes ways and features for users to interact with and control the dashboard outside of the actual dashboard area itself. So for example, if I open our website, oh, come on. And I click on one of the university logos outside of the dashboard area, that's going to toggle a change within the dashboard itself. Oh, let's go Chicago now. There we go. That will toggle a change within the dashboard itself. Now, that kind of functionality only happens with parameters. Also, the parameter functionality allows us to maintain this university selection if we wanted to go to a different dashboard. So let's go over to student recruitment and enrollment, and let's open the admissions dashboard. Now, this is going to be an example of one of the more complex dashboards that we built. But notice how when I changed to a different dashboard, the UIC Chicago selection was maintained. If we were just using quick filters on our dashboard, that university selection would reset every single time a new dashboard was opened. So let's go back to Tableau and let's open our admissions worksheet here. Our admissions dashboard, excuse me. So for some dashboards, we're presenting metrics that either have different metric formats, such as a raw number versus reporting a percentage, or different visuals entirely, like we'll see here with our test score graphs and our admin rate metrics. Now, these dashboards heavily utilize a technique commonly referred to as sheet swapping, which swaps and pops worksheets within different spaces within the dashboard based upon the parameter selections. And our admissions dashboard is a great example of this. So if I open this worksheet, or this dashboard, excuse me, here, I can see that within this list of worksheets, and I've done the counting for you, we've got 22 different worksheets that we're using here within the dashboard compared to 7 in our graduation rate and retention dashboard. So many of these worksheets rely upon a specific filter applied to them, which controls their appearance within the dashboard. Calculated fields are used extensively to create yes or no conditions upon which a worksheet displays. So for example, we've got the admit rate for incoming freshmen here displayed on the dashboard. If we open our admit rate combo chart worksheet here, we can see that we've got an admit rate view control filter applied to the worksheet. This is a view control calculated field which controls the appearance of both sheets. This actually will apply to the combo chart and the admit rate table. So if we toggle back and forth between a test score metric or an admit rate and yield rate selection, we can see how the legend in the bottom of the left-hand corner of the screen changes as well. So let's go ahead, just for illustration's sake, let's go ahead and switch to the ACT overall percentiles metric within our admit rate worksheet. It's important to notice that we're within the worksheet here. Okay. As we switch to that metric selection, notice our admit rate combo chart disappears. And that's exactly the behavior that we want to replicate on our dashboard. But if we go back to our dashboard, we can see now that that ACT overall percentile worksheet has now populated. Okay. And we can also see down here that our legend has changed. So let's go back to admit rate. We've got our percentile values, we've got our color legend. We go back to the ACT overall percentiles. Now we've got a different legend here. So again, we're utilizing that sheet swap and pop technique with tiny little worksheets like our legend worksheets down here. There are even separate worksheets to display the unique colors displayed for test scores for each of our universities. We select Chicago, those should change to a shade of red. We select Springfield, those will change to a shade of blue. So hopefully these examples have given you an idea of how we're utilizing scaling functions, SQL queries to build data sets that are capable of supporting our Tableau dashboards. Again, I want to thank everyone for attending our presentation today. And at this point, we'll go ahead and open it up to any questions.
All right. Okay, well, Nick and I are here. I know there's a lot of content. We wanted to share as much as we could about what we did to put these together, and I especially really enjoyed Nick's part about all the Tableau techniques that he used. Really interesting stuff. So any questions? Has anybody done similar work with IPEDS data? I know there are a couple different ways that you can kind of build IPEDS databases. There was I think it was an AIR seminar where there were some folks from East Coast schools who shared their IPEDS database that they built with R. And you can definitely do this in a lot of different ways. But that was very interesting, and I'm really glad they shared it, but it didn't work for us because we needed IPEDS data updated pretty much all the time. We have very strict and tough to meet deadlines. Basically, as soon as the data comes out, we need to put it out there for our board. And that's just the nature of the beast for us. But so we didn't have the flexibility to use the IPEDS database that had been built by some of those other folks in the AIR organization, because it doesn't get updated. They kind of update it when they have free time. So. Oh, I see a question here from Matt. How long did it take to put it all together? Hoo-wee. What do you think, Nick? I mean, we delivered the initial round of this last November. It's kind of still, even since November, been a work in progress. That one thing, I guess, that helped us put it together is we were able to do it in stages. So we did kind of we started with those static PowerPoint images in some parts of our website when we first released the website. And then as we got to the different points of the calendar in the board year where we would present our different set of metrics. At each board meeting, we present a different set of metrics. At least that's how we had done things in the past. It was very calendar driven. So we did kind of continue that in that initial iteration. When we started back in November, we only had one area of the site that had Tableau dashboards, and the rest were just static images. So we did take, here we are next November, right? And we just finished up with the last round of them. When did we finish that, Nick? Like a month ago?
Yeah, I want to say probably a month or two ago. Yeah, I want to say it probably took 8 or 9 months to have completed everything, all of the dashboards, and now we're sort of getting, into the next phase of it, which is, getting better about updating them with current year data and adding additional enhancements. And there's always a little bit of you got to gather buy-in and feedback from everybody in the initial parts, and there's a lot of insight and ideas about the design of them, and it's got to be bounced off the board too. So I would say that part took a little bit of time, a little bit longer time in the beginning, but really once we got that framework and that structure laid out for most of the dashboards, it wasn't too bad. But taking them one at a time was definitely an important approach because just of the scope of the project, it was easy to look at all these metrics and say, my gosh, I've got a lot of work to do, but just trying to take it one dashboard and one metric at a time. So.
And we probably spent I think we started maybe early in the summer last year to put do the data side of it. We knew that was the driver for everything.
Mm-hmm.
So yeah, we worked pretty intensely on that over the summer and into the fall to get things ready for November. So yeah, and fortunately we had lots of help. Sally Michael on our team was really helpful in terms of kind of bringing all the different people involved in this together and making sure we were all hitting our deadlines and that we were communicating with each other and communicating with the campuses and communicating with the board. There's a lot of communicating that has to go on in a project like this. It's not, the technical part is kind of the fun part in a way. The communication's very time consuming as well. So Sally actually really kind of bore the brunt of a lot of that communications part of it, which was very helpful actually to Nick and I to be able to focus on the data and the Tableau dashboards. So a huge team effort.
Absolutely.
I will say too that when Nick and I started early on, I know there's a lot of Power BI users out there. Some people use Power BI and Tableau. We did, I think we even had a bit of a moment of panic very early in the project where we thought maybe we should do this in Power BI and not in Tableau. There were just various reasons for that, but I don't know. I'm still not sure if we made the right call on that, to be honest. I'm real happy with the results, definitely, in Tableau. But I'll just throw that out there that I think you could definitely do something very similar in Power BI. I wouldn't know all the details. The devil's in the details, but yeah, we maybe 5-10 years from now, if we do another one of these, we do it with another technology. But the data behind it is so critical, and what Nick built out too with the scalar functions and SQL to be able to, not have to reinvent the wheel when at the 11th hour someone comes and says, hey, we're changing one of the peers for Springfield. You guys can recalculate all those metrics, all the percentile values, right? That's easy, right?
Yeah, exactly.
That's not easy, but it is now that we built that.
Easier for sure.
Yeah. Matt says sounds like a full-time job for each of. Well, kind of wish I could just do this full-time, but we do a lot of other things. This is maybe a small part, honestly. I don't know, but it's an important part. So. All right, well, we are at 12:30. I don't know. I guess we should probably wrap up. We have our closing session. Is that right, Katie?
There's a closing session. Also, I added into the chat a link to the session evaluation form. So if everybody could jump over there and submit your evaluations, and then from here, just go right over to the conference closer just a brief 15 minutes. And then, yeah, so thanks everybody for attending. Great session, guys.
All right. Thanks. Bye.
Bye.
Thank you.